This is House Planning Help episode 323. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down some of the major roadblocks that may get in our way. Today, my guest is Nathan Gambling from Beta Talk, the renewable energy and low carbon heating podcast. We're going to have a complete guide to air source heat pumps. Before we get into that, though, are you building or retrofitting a house? Hopefully that is a definite yes. That's what we always hope on this podcast. If not, tell me why you're listening. And I wanted to remind you that we do run a free Facebook group. And what's good about this is I think out of all the places, social media is great, isn't it? You're here, there and everywhere. But this closed Facebook group always comes up with really interesting questions. And perhaps a lot of people in the middle of construction throwing up those questions. So if you want to come and join us, we do our best to restrict spammers, keep them out. Talkselfbuild.com will take you there by magic. Talkselfbuild.com. Let's get to our featured interview. Nathan Gambling from Beta Talk, the renewable energy and low carbon heating podcast. I imagine it goes a lot more technical. You know, sometimes I have to rein people back because I know my brain will hurt if it goes too far. And I'm afraid that's the limit of this. So check out his podcast for more. We're going to explore air source heat pumps. Again, it's a topic that comes up quite a lot on this podcast, but never have we dedicated an episode to air source heat pumps entirely. I started by asking Nathan to tell me a little bit about his background.
I come from quite a unique background in heating. So my grandfather was responsible for bringing oil pressure jet burners over to this country from Sweden, sort of 60s, 70s. My great uncle was lead engineer and European energy manager for Unilever, and Unilever sort of, I think, one of the world's first corporations. They acquired Birdseye back in 1930 or thereabouts. And obviously Birdseye associated with refrigeration, which is heat pumps. And so he was obviously in charge of some of the biggest refrigeration plant in Europe. I did my apprenticeship with the MOD. After that, I wanted to go traveling and do all sorts of things. So I was able to dip in and out of the industry. Then got into teaching in 2006. I was asked by prison to come and teach the Sitting Guilds Level 1, Level 2. Really liked teaching. Then started teaching colleges. Did that for about 10 years. You know, the vocational education system in this country, in my opinion, is it's a big money-making machine. So we tend to teach people to be qualified rather than competent. So I come out of that, but I still wanted to facilitate learning. So I got into podcasting where I could disseminate and amplify the voice of really good engineers, because the biggest pain point for a homeowner is they just do not know who a good engineer is. It's got nothing to do with qualifications, accreditation, or experience, but you can be experienced in doing things sort of the wrong way for a lot of years. So that's kind of why I started up the podcast, to sort of disseminate and amplify their voice, because it's one of the most important voices out there.
Now, this may be taking a slight U-turn already, but what would you need to become one of these people that you're talking about?
The great engineers out there are constantly chatting with each other about different techniques, best practice, because heating is complex. I don't think people realize it's like my cousin always says, you know, heating isn't rocket science. It's far more complex than that. Rockets have thermodynamic systems on them. It can get very complicated. You can go right down the rabbit hole with thermodynamics. So the good engineers are the ones that tend to be really sort of, so I promote peer-to-peer learning, and you'll find now that we live in this world of computer-mediated communication, you know, things like your WhatsApp groups, Facebook groups. There's engineers out there that are organically just start to chat with each other just to learn about stuff. Because sometimes it's not always training, it's just familiarization with what's sort of current. And obviously this is a exponential industry now where technology is changing. I mean, there's so many fittings and products in the plumbing and heating world. I mean, it's astronomical. So it's about keeping up with best practice. Anyone can start up a plumbing company tomorrow. You don't need to be qualified. You just need to follow building regs, water regs. If you want to do gas is licensed. So obviously then you've got to go and get your gas tickets. You don't need a qualification to put in a heat pump unless you're doing it under MCS, which is where you're then getting a government grant. I mean, one of the things to think about MCS, it's accrediting the company. It's not accrediting the actual individual engineer. So to become an MCS accredited company, installation company, you will have to have a nominated person who's done the qualification, which is just a 4-day course, really. but that person could leave the next day, and then you could employ whoever to come and put your plant and equipment in.
Well, let's focus then on the individual who's either going to have a house or be thinking, I want to build a new house. And today I wanted to just focus on air source heat pump because we haven't dedicated an episode to that before. So let's keep things as basic as we can, but with good information. What is an air source heat pump?
A heat pump is basically something that moves energy from an evaporator to a condenser. That's it. And it uses vapor compression to do that. We use a refrigerant where we compress it and we can extract more heat. So they literally are everywhere. You know, that vending machine, Coke vending machine or whatever you want, that's got heat pump technology in it, a slush puppy machine, a Costa coffee machine. They're literally everywhere in the commercial spaces. So lots of people who will work in offices, they'll look up and think, oh, that's aircon. It's not actually aircon. It's actually something called comfort cooling. Air conditioning does exist, but it's very, very rare. But what they don't realize is that's heating them as well in the winter. So it's in cinemas, retail centers. If you go into sort of these old pubs that have now been turned into Sainsbury's or Tesco's, the amount of vapor compression technology in that is astronomical. It's all up in the ceiling, heating you and cooling you. It's all on their metal shelves that are keeping the products cool in the fridge cabinets. You'll find that, you know, since the 30s, our whole world is running on vapor compression technology. An air source heat pump is obviously extracting the energy from the air, whereas your ground source will extract it from the ground. I suppose one thing to mention is there's lots of energy, heat energy in the air, because unless you're down to minus 273.15 degrees Celsius, that's when atoms stop moving. That's when you don't get any heat energy. So anything above that, you've got heat energy. So even at minus 20, you've got astronomical amounts of heat energy. And then we compress that energy with a compressor, and then we release it out with a condenser. So they exist everywhere.
For a home, what would the hardware look like? We talked about the heat pump. Is the compressor within that, and how does it come into the house?
So, yeah, you've got different types of systems. So you're going to find that most people talking about heat pumps for the home are talking about an air to water system. So most people are very familiar with water running around their radiators or underfloor heating. So your source, your air, the source for the heat is your air. It's transferring that heat to water. So that's an air source heat pump, but air to water. Something like I've referred to, like in your offices, is air to air, which are actually starting to get a little bit more traction and awareness because they are a lot cheaper. And of course, they can do cooling for you in the summer. So you'll probably find a lot of new build people, or even retrofit, especially if you've got small flats or apartments. You can really, you know, an outside unit for a small flat is going to cost you about 500 quid, and an indoor unit about 200. You might need 2 indoor units, and you'll need an F-gas engineer to install that. And then you'll need a hot water strategy. So you might have an electric shower and then an under sink water heater for your kitchen sink. But most people, when they talk about air source heat pumps for a building, they're talking about air to water. So that your emitters, which are your radiators, your underfloor, you can even get radiant panels for the ceiling. They're emitting the heat into the room. You're extracting the energy from the air, and then you're emitting that energy into the room via water, basically running around rads or underfloor heating.
Can any house use an air source heat pump?
Theoretically, yes. So one of the ways I describe it or help people understand about, and there's this thing about temperature, that you need hot temperature to heat a leaky home. Well, the term leaky home is quite problematic. All homes leak. You could have a mild thickness of insulation around a home. If there's a temperature difference between inside and outside, heat will move. That's the second law of thermodynamics. I mean, it's going to move extremely, extremely slowly, but it will move. The average home in the UK, believe it or not, even though we get called leaky, is 8 kilowatts at design outside temperature. Now, what that means is the average day in winter is 7 degrees. The average coldest day is around -3. It varies a little bit where you are. So in London, it's -1.8. But that's the average coldest day. So we tend to design systems to be able to cope with that average coldest day. And most homes in the UK, they need 8,000 joules of heat per second to maintain 21 degrees inside when it's -3 outside. So 8,000 joules per second is 8 kilowatt. Now, what that means is when it's 10 degrees outside, your home only needs now 3.6 kilowatts. If it was 5 degrees outside, you'd need about 5.5 kilowatts. So that's quite important to understand. Your your power demand inside your home is constantly changing depending on what the temperature is outside, because heat moves quicker if there's a higher temperature difference between inside and outside. So unfortunately, even with gas boilers, we've been putting gas boilers in for a long time now at fixed temperatures. They should really be modulating their temperature flowing around that radiator depending on what the outside temp is. Some of your listeners would have been to, I don't know, a marquee at a wedding or even at a dance festival where you're inside that big marquee and it's getting very, very hot, even in midwinter. And that inside that marquee's got a flow temp of just 37 degrees. That's body temp. But if you put too many bodies into a space, we all emit 100 watts. We emit 100 joules per second of heat if we're moving. That average house that only needs 8 kilowatts -3, you chuck a party with 80 people, you'll maintain the temp. And if it comes up to like 10 degrees outside, boot a few people out, you only need 36 people dancing around. So you can weather compensate a party by just inviting people and booting them out, depending on what the temp is. So you can heat any property with low temperature. I suppose the best bit of advice I can give for people that want to retrofit or do a new build is the magic of getting really efficient air source heat pump systems is what we call narrowing the delta T between the source temperature and the sink temperature. So let me just explain that. So DT, delta T, just means a temperature difference. You're trying to match the temperature flowing around your emitters, your radiators, as close as you can to what it is outside. So if you've got this -3 outside and you're managing to maintain 21 inside with just 40-degree water running around your radiators, that's going to be more efficient than if the system was running 50-degree water around your radiators when it was -3. So if you design your system to be able to reduce that flow temperature in your emitters for the colder temperatures, that's when you start to see these really good, what they call COPS, coefficient of performance. And the way to do that is with emitter size. The more surface area of emitter, so that's a bit synonymous with people. The more people you've got in a room or a marquee, you've got more power being emitted. Now, we don't have radiators that can grow and contract in size yet. I mean, maybe in the future we'll have these shape-shifting radiators. So the way we account for the different power that we need, depending on the outside temperature, is to increase and decrease the flow temperature going around the rads. So when you design a system, what you're trying to do, the good engineers are trying to design a system that will give you the lowest flow temperatures possible for the coldest temps. And the way you do that is with emitter size. So let's say if I was building a new build, I would have underfloor heating and radiators at the same time. So I've got all this surface area of emitter. So I've got increased my power and I can have lower flow temps now flowing through the system.
Now, a lot of us are building very low energy houses that they often say do not put in underfloor heating because you're dealing with such subtle changes. Is this almost a separate category here? I know all the physics will be the same, but you're talking about a very small amount of heat that you need in the home.
Yeah, you are. Depending on the size of the home, obviously. And this is sometimes where air-to-air can come into play. So, see, with an air-to-air system, which is a lot cheaper. I mean, some people don't like the sort of comfort they give when they're in that office. They might be getting a dry air type feeling, but usually that's down to system design again. But you can get very small units, outside units, 2 kilowatt, 3 kilowatt. What you sometimes see with underfloor heating is people like it with air source heat pumps because it can provide passive cooling in the summer. You don't really get that with rads. But again, if you're going air source, you're then moving heat from inside and chucking it outside, and you've got that cooling effect as well.
Let's just talk a little bit on the outside here. So can it be on any elevation of the house, or are we looking to put it on the south side? How does this work?
Siting a heat pump can be problematic. As you would know, we've got some kind of archaic planning laws in this country. So sometimes that can be quite stifling. In England, for instance, you have to site an external unit. These are air to water, what we call monoblocks, a metre from the boundary. It does change actually in Wales and Scotland. I can't think what that rule is. But if you're in an area, or let's say, for instance, you're near the coast, the heat exchanger will be coated with a protective coating to sort of stop salt corrosion. Some people don't aesthetically like the look of them, so they will try and cover them up. Well, you don't want to cover them up too much because obviously you're extracting heat energy from the air. So that fan needs a certain amount of energy from the air. So it's sucking it in, and you don't want to restrict that. Terrace houses, obviously, you're restricted to sort of back gardens, aren't you, and things like that.
What about neighbours? Do they ever kick up a fuss over noise?
Noise isn't really an issue now. I mean, they have been in the past, but I mean, an all outside oil boiler, for instance, is noisier. You'll find some of the gas flues are even noisier. So noise isn't really an issue anymore. I mean, yeah, if you're siting it somewhere which is going to be near your neighbour's window and the thing comes on at the night time, they might be a bit displeased, but it's not something to worry about as much as what people do worry about, if that helps.
What about the sizing of the units in the first place? Or is there a process of how you would take a customer through this journey?
Yes. Now, when you size a heat pump, it's actually quite critical you get the size of heat pump right. I mean, lots of people have got 24, 30 kilowatt boilers hanging on the wall, and they tend to be that big because a lot of them are now combi boilers. So they're doing a combination of two things. They're doing your space heating, going to your radiators, and then they're also then heating your hot water, but they're heating it instantaneously. So if you want to heat water instantaneously, water is very hard to heat up. You know, it takes 4.186 kilojoules of energy to heat it up 1 kilogram by 1 degree. It's an astronomical amount of energy to heat it up. So if you want to do it instantaneously, you need lots of power. So that's why people see these badged up boilers of 30 kilowatts. But your heating load does. I mean, you can heat a 30-room house with a 30 kilowatt boiler. So when you size a heat pump, you do want to get it quite accurate. And historically, the way we do that is with a heat loss calculation. Now, heat loss calculations used to go on in this industry. Back in the 60s, 70s, early 80s, we were an employed industry, mainly by the British Gas Board's local council. So you'd have designers that were doing all the heat loss calcs. And then as we become a sole trader industry, heating engineers and it's not always their fault. There's a lot of marketing tactics that are pressurizing engineers to do things certain ways and perhaps not best practice. But we kind of lost touch with sizing systems. But that's actually now coming back in. So MCS will require you to do a heat loss calculation. Now, the trouble with heat loss calculations and U value, so that's RD SAP, SAP, it's a prediction. You're basically looking at the fabric of your home, you get your U value, but then you assume that every square meter of your home is performing the same. That never actually happens in the real world. So there is now methods where you can actually measure the speed of heat going through your fabric, and it gives you something called the heat and transfer coefficient. And once you know that coefficient, you know what power you need for any external temperature. This is very, very new to the industry. It is being used in new builds because what happens is you get an architect and the builder and they say, right, this is what per square meters this building is going to be. But of course, I mean, insulation, everyone thinks insulation's easy, but it's actually a science in its own right. And usually on a building site, the lowest paid person's putting the insulation in. So you've got gaps. And things like retrofitting, people putting windows in, you know, they might be a lovely triple glazed window, but people don't realize until they thermal image that the outside of it is leaking energy astronomically. So you can actually now measure heat loss. It's called heat transfer tests. It's being used to verify. So builders that are building homes that say they've got this particular heat loss, you can then go in with this equipment and actually test and verify that. Very, very beneficial for people retrofitting, putting lots of insulation in, because you can do an HTC test at the beginning, have all your insulation measures then done, and then do a post test to see if it's actually done that much. You want to reduce your kilowatt load now with this actual measurement, not prediction. So when you do SAP and heat loss calculations with U values, that's just prediction. You can get a real sort of understanding of how well your fabric is performing.
Right, I'll stop you there because you've said something very interesting, and I'm more and more for evaluating how the building work has been done. So, firstly, how similar, I don't know whether you know this, we chatted to Tom from Veritherm.
I was with Tom yesterday.
Right. So it's this sort of system.
Yeah, so you've got two kinds of systems. So Tom's system, Veritherm, they will go in with equipment to heat up your property. So they'll put electric heaters around, maybe fans to distribute that heat. They're going to put a load of sensors everywhere, temperature sensors. They're going to put temperature sensors outside. So they heat your property up to around about 25 degrees, and they know exactly how much energy they've put into their electric heaters to heat that property up. And then they shut it down. It's an overnight test. So it's a quick test. I suppose there's a little bit of disruption if you have to move out, but it's great for verifying new buildings. The algorithm just monitors the speed of heat leaving the fabric, and it gives you this heat and transfer coefficient. Another way of doing it is I'll put 5 to 6 data loggers strategically around the home. When I say strategically, you don't want people moving them. So if there's young children, you put them on a higher bookshelf, for instance. You put them around the home, you leave them in for 3 weeks. You take a meter reading of like your gas consumption. I would measure up floor area, window area, and orientation of windows, because once I've collected them after 3 weeks and plugged them into the sort of the algorithm, which is an algorithm built by Build Test Solutions, and that's been tested by Bayes to be very accurate. It takes into account the weather data, solar data. You do a final gas reading when you pick these things up. And that then also gives you the heat transfer coefficient. So once you know what your home needs, it's not plain sailing, but once you know what your home needs, you've got a greater understanding. But fabric first is, as you know, a bit of a buzzword. I always say measure first, because it's very easy for fabric measures to get very expensive, and no one at the end of the day knows how well they're performing. You might theoretically know how well you might have had someone say, well, you've now put this amount in and that's going to bring it down to this. Well, unless it's been put in very well, and that's actually quite hard to do. Some of these fabric measures are actually quite hard to do and get really, really spot on. So this way of verification is a great tool.
If I'm understanding you correctly then, so we are going to size after we've built the building, got everything as sorted as we think. Is that correct? Or are you doing some rough idea of what you think it should be to begin with?
Horses for courses. So if you're in a retrofit situation, you've got a budget and you want to do some fabric measures before you then sort of start to think about heating it. I mean, before I do my retrofit measures, I would actually measure the HTC, heat and transfer coefficient, do your measures, then measure this HTC again, because that does two things. That now tells you what your home actually needs accurately. It also means you might be able to bring your builder back and say, look, I don't think you've done a good job here, because you've only reduced the kilowatt load by about 1, and we were expecting it to reduce by maybe 2. But once it gives you this accurate measurement, and then you would design your heating system to that. I mean, if you're doing it under a grant system, MCS still want you to do this heat loss calculation. That's just part and parcel. But MCS now are very aware of measurement, measuring performance rather than predicting it. So we might see standards start to sort of change in the future.
You mentioned in there grant. What grants are available now? I know the landscape has changed again.
For the homeowner, it's the BUS, which is the boiler upgrade scheme. And actually, new builders, if you're not a developer and sort of building 2, 3, but if you're self-building your one property, you can actually access that grant, I believe. So that's the boiler upgrade scheme, BUS. That's going to give you sort of $5,000 off of the total cost. I mean, lots of people, when you're in a retrofit situation, always say, well, why is a heat pump costing so much more than a boiler? Well, with a boiler, basically someone's coming in and swapping a boiler in and out. With a heat pump system, you've got to change some of the infrastructure. Not always. I mean, some people think every radiator has to be changed and all the pipe work. Not always. There's no panacea. You have to really it's very individual to each property. And as we've just said, you can heat any property with a heat pump if you design it right. But I mean, there's no, if you're building a home or retrofitting a home and you don't need that grant for whatever reason, or you're not that bothered, there are engineers out there that aren't MCS that are still very, very good. Again, the poor old homeowner isn't going to know how to spot. I mean, one of the ways I always say to people that want to engineer is, just ask them a few questions. One of the questions I would ask an engineer is, what flow temperature are you going to design my system for? And you want them to sort of be saying the lower temperatures. We have had a sort of a historical case of where heat pumps are put in with fixed temperature, a bit like boilers. Boilers are all going in with fixed temperatures. They don't need to be. They should be compensating. Now, all heat pumps come with weather compensation, so they should be automatically adjusting the flow temperatures going around your emitters, depending on what the outside temp is. But you can set them at a fixed temperature. And unfortunately, that has been going on because it limits the warranty call outs and people going back to the system. So that's probably a first question you should ask an engineer. Do you weather comp your weather comp and your heat pump systems, or what design temperature of flow are you going to design it to? And that's going to come down to your emitters. So with underfloor heating, if they're going to be putting that down, a good question to ask them is, what centers do you put your underfloor heating down? Now, what that means is the space between the pipe. The underfloor heating market is a very overcrowded market. So all manufacturers are trying to sell their stuff. They will tend to design it for the engineer and give the engineer or the homeowner some lovely looking plans. of where all this pipe work's going. But you'll sometimes find they're at 200 or 150 centres. You want to really be putting your underfloor down at 100 mil centres, because then you've increased the surface area, and that automatically means you can run lower flow temps through it.
Is it likely that the company that we get involved will do the design and their people will also do the install and perhaps the check afterwards as well?
Yes, we are seeing a change. So I was one of the sort of people involved with MCS a little while back, saying, design is a bit different to installation. So if you go back historically in the plumbing and heating industry, you would have designers designing all this stuff, and then your fitters would go in and just fit it to plan. So there is now within MCS, a design qualification is now separate to installation qualification. You'll find most outfits out there do their own designs. There are umbrella schemes. So if a company isn't accredited with MCS, they will use an umbrella scheme who would do the design, and then your installers go in and work to plan. Again, there are companies out there that are doing the design who I wouldn't say are that great at doing it. I think people have just realised, or starting to realise, heating is complex. We've been in an industry where you can just literally plonk a boiler on the wall and walk away. Everyone's warm. It works. It won't work for as long as it should do, because they break down quicker. I mean, our country sells more boilers than anywhere else in Europe. I mean, up until 2016, we had the biggest gas boiler market in the world. And of course, that's then created a problem, because you've got so many companies now in this country trying to maintain them sales. They use all these different marketing tactics. So the big four in this country, Baxi, Valent, Ideal, and Worcester Bosch, that they incentivize an engineer to buy a boiler rather than repair. So they will fly you abroad to places like Las Vegas and Miami if you sell enough boilers. So they've got all these loyalty schemes that are actually incentivizing people to even oversize. You might be putting in 3 boilers a week. You've worked out for the next fortnight, your 6 boilers only need to be 24 kilowatts. You walk into the merchant and they say, we've got a deal on a 30 kilowatt. You get 150 quid cash back. So the engineer then thinks, I'll buy 6 of them then. And the person in the home ends up with an oversized boiler that's going to cycle a bit more than it should do. So that's a big problem. And it is starting to encroach into the heat pump industry. So the heat pump industry and everyone's awareness around heat pumps has been brilliant for people understanding that you can heat most homes with low temp, and your temperature should be changing anyway. That's compensation control. But we are starting to see marketing tactics. One marketing tactic with a heat pump is, we've got new refrigerant now that can heat water up to 60 degrees. So people think, brilliant, that's an instant swap out to a boiler. But you're going to pay a lot more electricity on your bill, because, like I say, the secret sauce of a heat pump is getting the lowest temperatures running around your rads as possible. That's when you get your efficient heat pump.
I have a couple more questions and then we'll wrap up. So just sticking with the machine for the moment, are all manufacturers on a level? How do we work out that bit of the equation?
They generally are all on a par. So, and one of the ways I always say is that if you wanted a really good family portrait, an oil painting on canvas, you wouldn't go and research what's the best oil paint. You'd want a good artist. And it's exactly the same with a heat pump. You want a good engineer. A good engineer is going to make most units work very well. You've got 3 distinct things going on. So you've got units that come from what we call the HVAC world, the heat and ventilation and air conditioning world. So they're your things like your Toshibas, your Hitachis, your Mitsubishis, Daikins, LGs. You've then got traditional heat pump manufacturers, things like Stiebel Eltron, Nibe, IVT. You then got boiler manufacturers that have now got into the heat pump industry. So they're your manufacturers like Wiesmann's, Valent. They are basically very much the same. It's that engineer that makes the difference.
How long will we expect a unit to go on for?
20 years plus. Ground source heat pumps a bit longer.
Do we need to do anything in terms of maintenance?
Yeah. So like anything, sort of moving, working, you have a maintenance schedule. So that's your service, your yearly service, more expensive than a gas boiler service. So you will also have to do that or maintain that to maintain your warranty. Different manufacturers will give different levels of warranty, but you'll have to have it, serviced to maintain that warranty. And it's always a good idea to get things serviced.
And I've heard of hybrid solutions before. So what does that mean?
So a hybrid solution is where you're hybriding it with another sort of heating technology. There's two ways to think about this. If you've got two different ways of heating your home, it can be advantageous. Out in Sweden, they'll have their heat pump and they'll have their wood burner. The hybrid thing is being used by marketers to say that, you know, everyone can have heat pump and you keep your gas boiler for doing the cold days. A lot of the time, you're never going to need a hybrid to do that. It's just, if you've got a good engineer, good designer, they're going to be able to do what they need to do. However, so let's say, for instance, my cousin still has his combination boiler to do his hot water, and he just stuck in, bearing in mind he's been doing this for 40 years, he's stuck an outside unit on his wall. This is air to air. He stuck a indoor unit over his bed because he wanted to keep cool. Well, actually, I think he put this unit up just to train his apprentices to cut holes through the wall. And that 4 kilowatt unit in his bedroom can heat his house for most of winter. So it's forced convection, blowing the air around. He's only got 2 bedrooms upstairs. The other one, I think the cat lives in mainly, so that door's shut. And then his whole downstairs is open plan. So that heat actually does get down there. If it's cold, his boiler comes on, and obviously his boiler is doing the hot water as well. So, you know, that's a very cheap setup. But you're going to get the marketeers are already doing this thing. Oh, you have a hybrid. So me personally, I think they're getting oversold. But that's not, I'm not saying if you're building your own home and you've got access to having different fuel sources, that's sometimes a good idea. You know, if you've got a wood burner and the electric goes out, you've got heat and you can put a kettle on it or something, can't you?
Is there any final thought that you would like to close with, or anything that we haven't mentioned perhaps?
Like I say, lots of people start to research the actual product. I think they get too hung up on the decibels and noise levels of different units and the SCOPs of different units. And SCOP is a theoretical prediction of the performance that each manufacturer will give in their literature. It doesn't mean it's going to perform like that, because again, it comes down to the installation. So my advice is you're going to start after now looking around, trying to work out who is good in this space. Like I said, it's extremely hard for the homeowner to do that because unfortunately, not all of them are good. Doesn't mean then, I mean, the cowboys not being good on purpose, but some people are out there just need a little bit of familiarization with best practice, and away they go. They're going to be good.
It is a fast-moving world, but it sounds like that's a great thing that you're doing. So keep up the good work and keep that community of engineers going. Nathan, really enjoyed my chat today. Thank you for all the information.
You're welcome. It's nice to meet you, Ben.
Get more online in today's show notes at houseplanninghelp.com/323. There's a summary to peruse. As ever, you can take your time, go through our takeaways. If you've got a comment or you'd like to ask a question, you can do that within the show notes or on social media. We'll give you all the links, of course, to Nathan and to the Beta Talk podcast, houseplanninghelp.com/323. A quick hub update, and then I'm out of here. We've put a new video in on our Kimver case study. So our in-depth video case studies, we film all the way through entire builds or retrofits. And that's what we've done at Kimver, which is a retrofit project of a Victorian terrace property. Guy Hargreaves, the homeowner. And in this particular chapter, we're looking at why buy-in with the subcontractors is so important, and some of the challenges on that if you're concerned at all about buy-in, maybe you don't want that person on site. Also, the impact of making changes once construction has begun. What does that mean? And if all the players do buy in and are committed, talking architect, client, builder, then that's a really strong recipe for getting through anything. You will have highs and lows on any project, but if you can just stay committed, stay the course, you're going to get to the end, and then you can maybe dissect all the learnings and so forth. So that's our current episode. We've also got the courses. We've quite recently put in a build systems course, the forum, the office hour, where you can chat to me about anything that's going on in your project or any resource that you're looking for. In-depth video case studies we mentioned, live training where we get guest experts in and probe them. All of this in our membership community, the hub, houseplanninghelp.com/join to find out more. Thank you so much for listening. The House Planning Help podcast is produced by Regen Media, content that matters.